Hello, this is a video response to 666norton420, who I should be calling Norton from now on. Norton referred me to a video on Google Video called, was it Universe the Cosmology Quest or something like that. So this is my take on what Norton made me sit through. First of all, it was a pretty good hatchet job, or attempted hatchet job. It's one of the better ones I've seen. They took all the accepted evidence for the Big Bang and did what they could to discredit. Some of the names involved were very impressive. I knew the names of Burbage and Dobson, who were both observational astronomers. They do have some theory, obviously, but Dobson, I've come across Dobson before trying to refute the Big Bang, and he didn't like it when one of his students, who understood the subject a little better than he did, started to push him on the matter. So, unfortunately, I'd have to say that people like Dobson and Burbage aren't theoretical physicists, so their grasp of some of the underpinning physics behind the Big Bang theory may not be the best in the world. That doesn't really apply to one of the other contributors, especially in part one, who was Fred Hoyle. Fred Hoyle was a very talented theoretical physicist. He was in fact the man who first used the word Big Bang, the expression Big Bang, and he intended it sarcastically. I forget what words they'd used to describe it before, something like the expanding universe theory. But Fred Hoyle was the first person to use the word Big Bang, and he intended to make a mockery of the idea of an expanding universe, but instead, unfortunately for him, it was a nice snazzy catchphrase, and it stuck. It's difficult to convey. I mean, first of all, I'm not a scientist. I'd call myself a dedicated layman. I've read about 100 books on physics. I've watched every TV documentary that's been going, especially in the last 15 years. Catch astronomy and astrophysics magazines. So I read what I can, but I'm not a trained scientist. But you do get a feel for it in strange ways. One of the things that I've got is a computer program which simulates the solar system, and you can play around with the values for objects, like their size and their density, and you can change their trajectories. So I'm forever destroying the solar system with black holes and neutron stars. They tend to be destructive little blighters. The reason I mention that is because although I don't understand the equations of gravitational physics, I get a feel for gravity and what gravity does and how it behaves, just purely by playing. So it's I'm sure some astrophysicists out there would hate me for saying it, but you do get a kind of a feel for gravity by just playing with gravity, without actually having the brain to understand the calculations concerned. Virtually the whole of that first episode was devoted to trying to bring into question the idea of redshifts. It would be rather like somebody saying that they had found a single duck-billed platypus, and that the theory of evolution should therefore fall. That's essentially what they were saying in that first documentary. They found a couple of galaxies with differing redshifts, seemingly sitting on top of each other. And because of that one galaxy, there may be 2 or 3, 4 other examples maybe even more, but you've got to remember how many galaxies there are out there. In that, they spent the entire first episode saying that because these two galaxies have different redshifts, and they seem to be sitting side by side, then that's it. Bring down the Big Bang. The Big Bang doesn't... The redshifts would have to be there for the Big Bang to be right. But that isn't... The redshifts are not the only evidence for it. By a long way. And to try to question the redshifts using just one galaxy as an example of why the theory should fall is kind of absurd. If you imagine grains of sand exploding from a central point, this isn't strictly accurate, I'm just giving you an idea of what we're talking about. If you imagine 100 billion grains of sand all exploding outwards, and the grains of sand towards the centre having a slightly pinkish colour, and the further the grains of sand go out from the centre of the explosion, the colour reddens. Now, what we see when we look at studies of the redshifts of galaxies at different distances to us, is that there's a smooth deepening of red as you move towards the outside, which is the redshifts getting higher the further out you go. Now, there are one or two grains of sand that don't do that. Well, more than one or two. There's probably hundreds or thousands, but remember, we're talking about hundreds of thousands of millions of galaxies. They do interact with each other gravitationally. So you can have, as we have right next door to us, a galaxy that isn't moving away from us. Andromeda is coming towards us because we've got sort of hooked in a gravitational dance with various objects throughout the history of the universe, and this has resulted in objects having near misses and going back against the flow of the tide, if you like. So not every single galaxy is moving away from us. But the vast majority are. If you look at the general picture, the redness spreads smoothly through tens of thousands of grains of sand going to deep red at the edge. And here's this guy, he's got a bluish piece of sand next to a red piece of sand, and he's saying that the whole theory is wrong. Leave you to think about that one. Quasars being kicked out of galaxies, rubbish. It would distort the shape of the galaxy, because a quasar is a very, very massive object, because it's so energetic. To be so energetic, because of E equals mc squared, it has to be massive. It would distort the spiral arms if it came out along the spiral arms. Also, once ejected from the galaxy, I don't see how this proto-quasar galaxy object is going to accrue enough gas to actually form another galaxy again. Also, we should see galaxies in the act of formation if this is taking place. We don't see it. Galaxies at great distances look more primitive than galaxies nearby. That lends credence to the Big Bang theory. You would expect the further back in time you look for galaxies to look less ordered, less spiral, and that's what we see. There are no quasars locally. If the quasar theory is right, that these things are proto-galaxies being spewed out, then we should see quasars spread randomly across the universe. We don't. We only see them at great distance, because the galaxies were primitive then, and there was too much matter trying to be in one place, and the quasar is just a jet of energy from the centre of the galaxy as it spews out the matter that it can't gravitationally swallow. We don't understand the process fully, but we're pretty sure that that's how a quasar is powered. But one thing we are sure of is there are no quasars nearby. We only see them at distance. That's because they only existed in the past when galaxies weren't as stable as they are now. It says in the text describing the video that it's comprehensive. It's not comprehensive. It only utters any sentences that are critical of the Big Bang. It forgets a ton of evidence. In short, my review: bullshit.